I'm going to do some quick examples with returns to scale. This is a lot from the last video. So a fairly common exam question will give you a production function like any of the ones here. And with that, you're going to be asked to determine if that production function has increasing, constant, or decreasing return to scale. It's fairly straightforward. The general methodology is to double all of the inputs, or triple. Double it to keep it simple, and see what happens to your output. You sort of just work with the equation a little bit and substitute a doubling of your input to try and see what happens. So let's start off with A. It's a fairly simple production function. Output is just equal to 2 times the amount of capital multiplied by the amount of labor. So I'm going to denote a new level of output. I'm just going to call it Y bar. Okay, and Y bar represents output when we double all of our inputs. So let's say we go to, and we're going to double the amount of capital. So this is going to become 2K. Brackets, so it's a bit easier. And then 2L as well, because we're doubling all of our inputs. Okay, so we can probably see, we can just bring these 2's out to the front in a sense, because it becomes 8KL, which we can actually see here is 4 times KL. So the key is we're going to want this 2KL. We're going to want this sort of original level of output. And that's sort of why I broke this 8KL down. Okay, so we're always going to be looking for that. We always want to try and come back to that. Here it's nice and easy. 8KL kind of breaks down into this in a fairly straightforward manner. So this is quite clearly 4 times Y. Therefore, since 4 is greater than 2, and 2 is the scale, have increasing returns to scale. I'm going to be really lazy. I'm just going to say IRS. Okay, we want to rearrange, and we want to try and get it into that sort of original Y 2KL, and then see what we've got out the front. And since I just doubled my inputs, and I'm getting 4 times the original output, that means I have increasing return to scale. Okay. So, slightly more complicated here. We now have powers involved. Okay, so I'm going to do the same thing. I'm going to say Y bar equals 2L squared. So just remember, we're doubling the 2L here. Okay, so the 2 is also going to get squared. And we're going to do the same thing over here. K to the half. So, we can probably see we're going to want this again. We're going to want this L squared and the K to the half. The best way to do this is, again, get those 2's out the front. Okay, so I can sort of rearrange this. 2L squared is equal to 2 squared multiplied by L squared. 2K to the half is equal to 2 to the half times K to the half. And then, by our index laws, when we're multiplying 2 numbers with the same base, so 2 squared and 2 to the half, we can just add those powers. Okay, so it becomes 2 to the 2.5 L squared K to the 0.5. So again, the reason I've done this, the reason I've brought this 2 out front, is because I want this original L squared K to the half, L squared K to the half, and now I have it. Okay. And I can probably see this is 2 to the 2.5 times Y. Okay, this is very general. If you're in an exam, you're going to want to write words in here. You're going to want to write something in here. Say we double inputs or something like that. Say we double inputs. Okay, put some words in there so they kind of know what you're doing. Yeah, so that's B, and then therefore increasing returns to scale. Reason for that being 2 to the 2.5 is obviously greater than 2. You can tell this is going to be greater than 4. So it's increasing returns to scale again. We've only doubled our inputs, but we're getting more than 4 times the original level of output. Okay, so C here. This is kind of a slightly more advanced production function where you have maybe total factor productivity. In this case, I'm just going to treat A as exogenous. Okay, not going to worry about it too much. It's just kind of it's a common form for a production function. and it's good to know how to deal with. So let's say again, same deal. So what we're going to notice now is A is not going to be doubled. A is not really an input. A is just exogenously set. Maybe it's technology, maybe it's weather, maybe it's all factors like that, maybe it's CFP. So I'm going to leave A as it is. I'm going to again take 2L to the half. And then I'm going to go 2K to the half. Exactly the same deal as last time. I'm going to bring 2. A at the front doesn't change. 2 to the half. L to the half. I'm just expanding these powers here. 2 to the half. K to the half. And again, we can see it all coming together. I'm going to want this original A, L to the half, K to the half. I have the A, I have the L to the half, I have the K to the half. Just have these 2's now. I'm going to bring 2 out the front. So it's 2 to the half multiplied by 2 to the half. We add those powers, get 2 to the 1, 2, and then we're left with that. That's not meant to be a Z. Why have they done? Oh, it's 2. Sorry, poor handwriting. And then L to the half, K to the half. As we can see, that is just our original Y. We have, therefore, that's constant returns to scale now. Okay, because we've doubled our inputs, all of our inputs, and we now have double the output. Okay, so it's kind of a 1-to-1 ratio with that scaling up of inputs and the scaling up of outputs. So hopefully that's kind of cleared it up. Generally, you just want to do this sort of double methodology. It's quite clean and easy to use. Just to remember, the complicated thing is the powers. You must include the 2 in that power, okay? Because it's the level of labor to the half, and say we double that level of labor, we need to include that double in that to the half power. Cool. Okay. Yeah, that's pretty much it. Maybe do it slightly more officially / with slightly better form than I have if you're in an exam condition. But that's basically how you identify returns to scale with a production function. Thank you very much.